Now, in this particular question, we are going to give you all a chart and you all are supposed to complete it. Great. But before that, let me give you all a chart that I have prepared specifically for this particular question. What have I done for you all? I have given you all the names of the first 20 elements of the periodic table. What are their atomic numbers? What are their symbols? I have also given you all the electronic configuration, as well as the number of electrons present in the last shell, present in the valence shell, called as the valence electrons, and therefore the valency. This happens to be till silicon, which is the first 14 elements, and after that we have the next 6 elements over here from phosphorus to calcium onto the screen. This particular table will help you out to solve the question which is going to follow. Let's begin. So that's the chart that we need to complete. Think about this carefully. I have silicon, atomic number 14, configuration 284. How many electrons in the valence shell? 4. It can gain 4 electrons and therefore the valency is going to be 4. So that is going to be my first answer. In that particular case, that will make silicon stable after it gains those 4 valence electrons. Next we have fluorine, atomic number 9, configuration 2,7. How many electrons in the valence shell? 7. Initial configuration 2,7, desired configuration 2,8 requires 1 electron and therefore the valency for fluorine is going to be 1. Great. Then I have boron, atomic number 5, configuration 2,3, has 3 electrons in the valence shell, loses those 3 electrons so that the new configuration is 2, because that is the configuration of the nearest noble gas, helium, which is obviously stable. So configuration is going to be 2,3, has 3 electrons, loses them, and therefore the valency is going to be 3. Great. Who do we have next? We have beryllium. As far as beryllium is considered, its atomic number is 4. Configuration is going to be 2,2. It is going to have 2 valence electrons. Great. The nearest noble gas is again helium. To reach there, it is going to lose 2 electrons and therefore the valency is going to become 2. So that's my answer. Neon, interesting one. Atomic number 10, configuration 2,8, already stable according to the octet rule. Neither loses electrons nor gains electrons and therefore the valency is obviously going to be 0. And finally we have magnesium, atomic number 12, configuration 282, desired configuration 28. For that it has to lose 2 valence electrons and therefore the valency is going to become +2. That, my dear friends, is how you solve this particular table.